we are live. Hello, everyone. This is Flask. Hello. Welcome. I have here with me David again today. Hello, David. How are you?
Hello, I'm good.
Perfect. So, Dustin, you're the first one. How are you today?
Hi, I'm good. How are you doing?
Good. Where are you streaming from?
I'm in Austin, Texas.
Oh, cool. Awesome. And you're talking today about some Google Cloud uses of Flask, right?
Yeah, I'm going to talk a little bit about, I'll talk about it. We'll see. Hey, everybody. I'm Dustin. I'm DI Codes on Twitter. Excited to be here for the first FlaskCon. I'm a developer advocate at Google. Ironically, the YouTube stream is not allowing me to present this talk, so we're on Twitch now instead. Glad to be on Twitch. So I'm a developer advocate at Google. That means I'm focused on supporting the Python community on Google Cloud. For me, this is like an overlap between things in Google Cloud and things in Python, and this overlap is actually like pretty huge. There's a lot of overlap between Cloud and Python. I do some other Python stuff as well. I'm a director of the Python Software Foundation. I'm a maintainer of Python Package Index, and I'm also organizer for my own conference, which is going to try and do the same thing in a couple months. So we'll see how that goes. So a quick disclaimer, I do work for Google, and this talk is going to be about some Google products, but I'm not here to sell you anything. Instead, I'm going to try to show you how Flask is an important dependency of Google Cloud, how we use it in some couple different ways, and how our users use Flask on Google Cloud as well. So yeah, this talk is all about how Google Cloud uses Flask. And I'm going to talk about maybe three kind of key areas. One, the very first serverless Python platform, which I think was on Google Cloud, and we'll talk about what that looked like. Two, we'll talk about what's under the hood for some of the Google Cloud products. And three, we'll talk about a new Google Cloud product that is also pretty interesting. So the very first serverless Python platform, usually when I'm giving a talk like this, I'm like, does anyone know what this might be? And the answer is this. It was App Engine. So App Engine was launched in 2008 to much fanfare, and it was kind of like the very first platform as a service thing. It was also kind of the very first place where you could go and deploy Python code, deploy a Python web app. This is the big bullet points for App Engine in 2008. Dynamic web serving, full support of common web technologies, some other stuff, fully featured local development environment, that kind of stuff. So it was a pretty, I think it was a tool that was kind of ahead of its time, right? When people first saw it, they kind of didn't really know what to make of it, and they didn't really know how to use it. But the goal was to basically allow you to take this Python web application and deploy it into the cloud. I went back and looked at some tweets from that time because I thought they were pretty fun. So this person says, Google App Engine preview release, web applications on Google infrastructure, easy to start, easy to scale. This person, someone asked their opinion on cloud computing, and she said, cloud computing is like a huge smoothie with many straws. That smoothie is Google App Engine, and I'm drinking that shit. And this person said, depending on how long it will be the only supported language by the Google App Engine, Python might finally get its day in the mainstream sun. This was in 2008. So Python, it is, I guess, still kind of a little underground, but yeah, definitely has gotten its day in the sun. So this is a conference about web frameworks, right? About a web framework. You might be asking, but what web framework were you able to use with this old version of App Engine? And the thing is, App Engine's launch in 2008 predates Flask, which was released in 2010. So yeah, what was it using? And it used a web framework called, very simply, Web App. So I think a lot of people probably haven't used Web App before. It was a WSGI framework that was built by Google just for App Engine. And it was from so long ago that I actually had to go to archive.org to get this documentation, because now if you go to it, it tells me that the Python 2.5 runtime has been decommissioned and you don't look at these docs anymore. So yeah, it was kind of an interesting little framework. And in some ways, it did some stuff that was later inspired by Flask, and Flask was inspired by it a little bit, I think. So pretty soon after Web App was created, there was a second project, Web App 2. And this is by a third-party contributor, Rodrigo Moraes. And this sort of started as a fork of the Web App framework, and then it was eventually included in the Python 2.7 runtime. It became, I think maybe more people are familiar with Web App 2 because that was actually like a little bit more usable, a little bit more widely used. And so this was maintained externally to App Engine by third-party contributors, and it was supported by Google, but not entirely maintained by Google. And so kind of an interesting thing about Web App 2, so the creator of it, Rodrigo, so it might be a little hard to see. He is credited as one of the contributors of it. But he also, Web App 2 also included code or ideas ported from other projects, including Workzeug and Flask. So sort of IDs are going back and forth between Flask and Web App 2 when he created this. And actually, Rodrigo was an early contributor to Workzeug as well. So there's a bit of overlap here. So this was still like back in the day, though. So you might say, well, okay, what framework are we using now? What can I use now on App Engine? And the answer is basically anything you want. App Engine now has what we call a second generation runtime. And this lets you bring any WSGI app that you want into your Python runtime. So this is a slide I took verbatim from another talk I gave. And basically, whenever I'm recommending someone to use Python on App Engine in Google Cloud, I show them this little Flask Quick Start, which I'm sure everyone has seen before, and is like basically the simplest Flask app you could create. And this is what we recommend. Like this is the easiest way to get started with App Engine on cloud. And actually, like this is all through our documentation as well, right? So if you go to writing a basic web service for App Engine, all the examples use Flask. And so it's really nice, especially if you're a Flask user, it's going to feel really familiar because everything's going to be in Flask. So quick recap, you can use Flask with App Engine, specifically with the second generation runtime, and you can use any other WSGI framework as well, but Flask is what we recommend. But here's the thing, App Engine doesn't really use Flask. Like under the hood, the things that we use to make App Engine run isn't actually totally dependent on Flask. However, we have another product, and that product is a little more interesting to look under the hood. And actually, usually when I say under the hood, this product uses, I say this product uses Flask. And the product is Cloud Functions. So Cloud Functions is a way to basically write a Python function that can respond to either an HTTP request or a background event. Something like if you drop a file in a cloud storage bucket or it receives a pub sub message, it can basically just run a Python function and do some activity, connect to some APIs, do whatever you want to do basically. Just it's a little tiny Python function that you can deploy. And we have Python 3.7 and 3.8 runtimes for Cloud Functions. So these are sort of modern runtimes that you can write Python code in. And a Cloud Function kind of looks like this. So this is just, again, the very simplest example. It's a function that takes a single parameter. This is an HTTP function, takes a single parameter request, and then it returns some string. And what this will do when you deploy it, it'll give you an endpoint that you can hit in a web browser or with curl or something like that, and it will just respond with hello world. And you can do anything you want in between, right? It needs to return a response, but then you can do literally anything in this function that you can do in Python. The other nice thing about Cloud Functions is you can just pull in any dependency that you want just by putting in requirements.txt. It's pretty straightforward. Cloud Functions has a really nice free tier with like millions of invocations per month. But again, this is a Flask conference. So you might be sort of wondering, okay, like I have to write a function that responds to, takes this request argument. What is it, right? Like, is it some weird Google thing that I have to like read the documentation to understand? And the answer is no, right? If you were gonna statically type this function, this is what you would do. You would import Flask, and this object is a Flask.request object. So that means that everything that you're familiar with interacting with the Flask's global request object, you can do the exact same thing inside of a Cloud Function, right? You can request.args, you can request.form, files, get the JSON, like depending on whatever you want to do with this function, you can interact with it the same way you would with an endpoint and a Flask app. That's super nice. And it means that all the documentation is Flask documentation, right? It's not Google documentation at that point. And so the other nice thing about this is you can also return anything you want the same way you would in a Flask app. So you don't have to return a string. You could return a Flask response, right, with a custom status code. So you might be asking, all right, this is pretty cool. Looks like this is kind of basically Flask. This Flask is in here somewhere. How does this work, right? So we have Cloud Functions on one end, we have our Python function on the other end, and there's something happening in the middle. We know that we've established that Flask is mixed in there somewhere. Important thing to note is that Workzeug is not a production HTTP server. So if you're deploying Cloud Function to production, you need something else. So maybe there's something like Unicorn in there as well. But then there's other stuff happening too, right? Like you're not defining the application, you're not adding endpoints, you're not doing any of that stuff. So there's magic as well. And so all of this together, all of this Flask and Unicorn and magic all mixed together is what we call the functions framework. And you might think that this is kind of like the special sauce of Google Functions, Cloud Functions, and that maybe because it's our magic, thing, I can't talk to you about how it works, but I can, and I'm really excited to, because the reason I can is because the functions framework is completely open source, right? So we publish functions frameworks for all the languages that Cloud Functions supports, including Python. And the Python one uses Flask, obviously. This is also published on PyPI. And the functions framework actually ends up being a couple different things. First, it is a function to app converter, right? It's that bit of magic that can look at a Python function and do everything necessary to turn it into a Flask app. So if you look at the source for a functions framework, I encourage you to, if you have experience with Flask, it might be interesting to you. I think it's basically the ugliest Flask app that's ever been created. It does a bunch of very weird stuff. It doesn't look super idiomatic. However, I will say that Flask's API makes it super easy for us to do some kind of weird stuff here in order to make this possible. In addition to being a function to app converter, though, the functions framework is also a command line tool and a local emulator. So that means that if you have a function defined like this on your local file system, you can use the functions framework to just run it locally. So you can pip install functions framework, and then you can invoke functions framework. You can tell it the name of the function that you want it to invoke, turn on debug mode, and you'll get Flask with a live reloader, which is pretty nice, which is all the same live reloader. Everything's already baked into Flask. If you don't use the debug flag, it will just use the production WSGI server, which is GUnicorn. Then you get GUnicorn there. You don't get live reloading, but this is suitable for production use. So you get this sort of like nice development experience locally, where if you have debug mode on, you can just be editing your function, hitting it in a web browser or with curl or whatever, and just be totally testing it locally without needing to manually deploy it. So in addition to those two things, the functions framework is also part of the Python runtime for Cloud Functions. So this means that it's actually in part of what we use when we deploy, when you, the user, deploys a function to Cloud Functions. So part of the runtime means that there's probably some more to it, right? Like someone actually has to like invoke this framework and do some other stuff, right? And so the way to sort of think about that is, in addition to the functions framework, all of this exists within this container image, right? There's sort of like this box that contains the user's code and the functions framework, and that gets invoked. And you might think, okay, great, like this is the special sauce that Dustin can't talk about. But I want to talk to you about this too, because this is also cool and open source. So we use Buildpacks for this. Buildpacks are, you can think of them sort of as recipes for automatically detecting a certain type of an application and then turning it into a container image, so like a Docker image, for example, all without actually needing to use Docker or define a Docker file or anything like that. And so Google Cloud has published Buildpacks for converting functions into container images and some other stuff as well, because we have a bunch of infrastructure that runs with container images. So this is actually what we use internally when you deploy your Cloud function. You send us your Cloud function, we run the Buildpack on it. It detects that it's a Python Cloud function and builds this container image around it. And then that's actually what gets deployed internally to serve your Cloud function. So when you use Cloud Buildpacks, it's sort of like this. This is the same function we had before. So this is just sitting in your local directory, just a regular little Cloud function. And so then you, after you've installed the pack tool, you can run pack build and then give your image a name. And it will automatically detect that this is a function that's been defined with the right argument for a Cloud function. It will build it. It will install the functions framework and install GUnicorn, all the other dependencies. And then it will turn it into this container image that is then suitable to do whatever you want with. One of the things you might want to do with it is run it locally. So you can Docker run that image that you just built. And just like invoking functions framework, it will invoke all that inside a container, a little more isolated, a little more deterministic maybe. So then you can, again, you still have that, you can do that development loop where it's reloading if you turn on the reloader. And yeah, you can then take that container image and then go anywhere else with it, basically. Yeah, Cloud Functions, let's recap real quick. So Cloud Functions lets you write HTTP or a background function in Python. The framework is what allows you to turn a single Python function into a WSGI app in Flask. And then Cloud Buildpacks is the tool that's used to turn a container into a cloud image. And so you might be asking, okay, the image stuff is nice. It's nice to not be able to use Docker. But why would I, as a user, want to turn my function into container image, right? Like I don't actually need to do that to deploy to Cloud Functions. And you're right, we use it internally, but you don't need it for Cloud Functions. However, we have another product that does work really well with container images. So let's talk about Run, don't walk to your nearest cloud. I want to talk to you about Cloud Run. So Cloud Run is a newer product of ours, and it's basically stateless HTTP containers in a managed environment. So you build a container image, and you deploy it, give it to us, and the container image has to do a certain number of things, but then it's deployed. So Cloud Run also has a free tier, very similar to the Cloud Functions free tier. And you can sort of think of it as service. You can write this Docker file, build the image, send that up to Cloud Run, and it will start a web app, run a job, do whatever you want to do. Like really, the world's your oyster. Anything inside the container image that you want to do, you can do. But you can, so this is a sort of contract for the container. So it has to listen for requests on the local IP on a specific port that's defined by the runtime. It has to start an HTTP server in 4 minutes. And that's it, basically. Those are the only limitations. So this means that your container image can run code written in any language of your choice, any base image, any framework, like literally anything that you want, as long as it responds to HTTP requests, it works. So when you deploy to Cloud Run, this is what you do. You can build it with Cloud Build. So you can run gcloud build submit and give it a tag name. And this zips everything up, sends it to Cloud Build. That turns it into a Docker image, and then you tag it. And then that tag is what you actually tell Cloud Run to deploy. But you don't actually have to do this. Instead, you can use something like pack. So you could pack build, give it a specific tag name, like this GCRIO tag, and then you can deploy that instead to Cloud Run. So this means that you don't actually need to send everything up to Cloud Build or use Cloud Build at all. Your Docker images can come from anywhere you want, and then you can deploy those to Cloud Run as well. So this is really nice, because if I wanted to take a Python function and not deploy to Cloud Functions, but deploy to Cloud Run instead, I could use pack to turn this into a container image and deploy that directly to Cloud Run. And then the migration path is really easy, right? So it's the same function, nothing has changed, same runtime, nothing has changed. The function behaves exactly the same way. It's just now deployed to a different product. So to recap, Cloud Run lets you deploy any container image to the cloud, and these images can be built any way that you want. So that's sort of my quick intro to how Flask and Google Cloud interact, and how users can use Flask on cloud and vice versa. I want to thank the organizers. I know that there's been some technical difficulties, but I've been using Flask for a long time. I love Flask. I'm really happy that it's one of our recommended tools that we use with Google Cloud. And yeah, I'm happy to save Q&A for the Discord channel, or you can catch me on Twitter instead, just to save some time, because I know we're running a little bit behind. But thanks everyone. Thanks for watching. Feel free to reach out and let me know if you have any questions.
Awesome. Thank you. Thank you very much. Yeah, great talk. And your questions, maybe one question we could take, or shall we just?
Yeah, sure. If there's time, yeah.
Yeah, perfect. So let's see. Do you have anyone has any questions? Anyone would like to ask anything? We have someone on Twitch saying great talk, and asking what is your take on type annotations. I just have Flask re-uploaded yesterday, and I noticed the type hints or type shed for Flask are pretty incomplete. While I created a PR on type shed, it feels a ton apart between Flask and type shed. Also, type hints get merged without any Flask dev looking at them.
Yeah. So yeah, my thoughts on static typing. I love static typing. Obviously, static typing, I think, is not ready to be used everywhere, especially if you want to use it with third-party libraries. A lot of libraries haven't taken the time to add static typing yet, and that's okay. So it takes a lot of work to add static typing to a code base, especially one as complex as Flask. I'm not a Flask maintainer, so I can't really say what exactly the plan is there. It sounds like maybe there's some work. I would encourage that work to continue. But yeah, I mean, static typing. I have a talk also about static typing. I'll be giving at EuroPython later next month, and I'll talk a little bit about why it's awesome. But yeah, I'd recommend using it. It's pretty nice. I think sometimes there's a bit of confusion about whether the library itself should ship type annotations or whether that should be in TypeShed, but I think that's sort of starting to get sorted out. So yeah, I would David, I think, was going to respond in the Discord, maybe with some thoughts about how Flask is going to use static typing. So I'll let him answer that one. But yeah, thanks for the question.
Cool, perfect. Thank you. Thank you for answering.